Okay, guys, here's what your sketch and the final sketch from today wants to look like, okay? We're looking at what we call common external tangents. Okay, these two circles have this one tangent, CD, in common, all right? And the problems you have in 4, 6, and 7 from the worksheet are going to ask you things about, well, how do I find this distance AB between the two? Or how do I find that length of DC, okay, that length of that tangent? All right, so those are things we want to take a look at. One thing we bear in mind, of course, these are circles of two different radius length, two different radial values, okay, which do not touch. And so we're going to take a look at this in just. Okay, so I'm back, and what I've done is I've constructed two circles, as you can see, with one tangent. Now, all right. Uh, what I want is I want a common tangent, so I want this circle to touch the smaller circle at only one point, okay, so that it's tangent. Now there's four different kinds of tangents that can be formed here. There's one that we can see here, and one that we could possibly get down here swinging this around, okay. Those are called external tangents. Then there's the ones that are going to crisscross in here, which are going to be like this. They're going to be the internal tangents. There's one, and then I guess I get another one swinging around like that. Okay, so for future reference, we got between any two circles that are not touching, okay, we got 1, 2, 3, 4 common tangent lines. Okay, now we're only concerned with this one that is kind of going to meet this at a right angle. Now that's a little hard to do, so we're going to swing our radius around. We're going to try to force this to happen. It may or may not happen, but we're going to try to get the best image we can. Of course, we know now what we want to do is we want to create this a tangent here. So we're going to create a perpendicular, right, to this radius at that point of tangency, and we're going to try to swing these around so that they line up and become one. All right, and that's going to be the best thing we can do here to try to make that appear like a common tangent. Okay, it's going to take a little tweaking out, and if I don't quite get it, then I'm not going to waste a whole lot of time with it. Okay, but we're trying to move it to that point. We're almost there. Okay, so let's say we're there for all intents and purposes. All right, now okay, we're going to fake it out and just presume that this is the case. I'm just going to hide this guy because it's going to just take away from the image. Now, part of the problems that are, we should assume now that this is a right angle, right? Because that's a common tangent. I know it's just not quite there. Please don't get obsessed about making it right there. There it is, close enough. Okay. Now, a couple things. So some of the problems asked, okay, well, what is the distance AB given CD? Or the other way around. What is the distance CD given AB? Okay, well, let's just draw our segment AB right in there. Okay. Now, in order to find those distances, we need to construct a right triangle. So what I'm going to do is I'm going to take this distance AB and I'm going to shift it. I'm going to translate it. I'm going to translate it along segment AC. So remember, select A, select C, and go mark the vector, and then take the segment, okay, along with those endpoints, A and B, and translate that, translate, okay, so that now what we have here, if we look, and we'll label this point over here, okay, as our, label that point as point E, let's say, okay, and now what we have is a right triangle. We have the right triangle CDE, correct? CDE is a right triangle okay? The hypotenuse, which is CE, which is the same as AB. So the hypotenuse of that is the distance between the two centers of the circle, okay? Because the right angle is here. What's the length of DE? Well, DE is the large circle radius minus AC, the small circle radius, right? Because AC is going to be the same length as ED, because these segments are essentially going to be parallel. Well, they are going to be parallel. So basically, what you want to do is to draw those two tangents. You want to take this distance between the centers, and you want to translate that up so that you have a right triangle here, okay? That the triangle right here, let's just kind of outline that. This, construct the triangle interior, okay? All right, let's see. All right. It may or may not want to do it, okay? So construct the triangle interior right there. We want to look at that triangle, which is going to be the right triangle, okay? That right triangle, all right, has the hypotenuse CE, which is the distance between the two centers, and it has the length of the tangent segment CD as one of the other sides. DE is the difference between the two radii of the circle. So that's the setup. That's what we ended up getting over here on the previous page, okay? And you know, with that being the case, you should be able to answer those problems relevant to the worksheet over here, those couple guys, okay, right here. So you're essentially going to draw that segment, shift it up, okay, and look at the right triangle, find the missing pieces via Pythagoras. And you have 3 of those problems with different number values for each one. So just be careful how you do that. Get that sketch pad drawn up real nice. I'd like to check that, finish that, okay, and move into the next section, outlining that for tomorrow, and you'll be in good shape, okay? Thanks a lot.